This example defines three functions. F of x is the absolute value of x, g of x is x squared minus 4, and h of x is 1 over x minus 5. And the first thing it wants us to do is find f of g of x and its domain. So a composition, right, I read this as f of g. It could also be said f composed with g of x. But a good thing to do here is write it in a slightly simpler form, f of g of x. And what this tells us is we're taking the entirety of g of x and plugging it in for the x in f of x. That sounds complicated, but what it means is we're taking all the stuff that's g of x and just replacing the x in f of x with all this g of x. So when we do that, right, all of it goes into the absolute value. We get absolute value of x squared minus 4. Okay, so the composition, once you're used to these, it's not so bad. The domain is a little trickier. The domain of f of g of x is the set of all x in the domain of g of x such that g of x is in the domain of f of x. Now that sounds terrible, but let's take a look at what this means. Let's unpack it a little bit. So what this means is you start with the domain of g of x. Next, you compute the composition f of g of x, and then you find any additional domain restrictions in that composition f of g of x. Okay, so let's give it a try in this example here. Let's look at g of x. Well, g of x is simply x squared minus 4. Well, that's a nice polynomial. The domain is all real numbers. That gives us no problems whatsoever. So the domain is all real numbers. Okay, so we're good to go. We haven't had to throw out any points from our domain. So next we do the composition, which is already here. And now let's look at the domain of that. The domain of f of g of x, well, there's nothing in here that gives us a hard time, right? X squared minus 4, nothing's prohibited there, and taking the absolute value doesn't make any other x values prohibited. So the domain of this composition is also all real numbers, right? So since we didn't have to throw out any points for either of our domains, that's going to be our answer, all real numbers. Let's try another one. For part B, we're trying to find f of h of x, which we can write as f of h of x, which tells us that we take the entire function h of x and plug it into the x in f of x. So here I'm taking the entirety of h of x, plugging that into the x in f of x. All right, when we do that, we get 1 over x minus 5. Okay, which, because this is absolute value of 1, that's 1 anyway, we can simplify it down a little bit to write it as just 1 over the absolute value of x minus 5. Now, there we go. Now onto the domain. To find the domain, you start with the domain of the inside function. Okay, so this is the domain of h of x first. All right, so we can look right here and we note that right off the bat, x does not equal 5, right? Because we take that denominator can't be 0. When we solve it out, we get 5. All right, so that's one restriction. Then we do our composition, and then we look at the final result and see if there has to be any additional restrictions. Well, no, there's not any additional restrictions. So our domain is simply everything except for x equals minus 5. So, everything except for x equal 5. All right, so we'll write that in set builder notation, x such that x does not equal 5. Okay, so let's try one more example. For part C, we want to find h composed with h of x. So h of x, we're composing a function with itself along with its domain. Okay, so what this means is we're taking the entirety of h of x, 1 over x minus 5, and plugging it in to the x. So, okay, so h of x is, all right, so 1 over, now instead of x, we write the function again, 1 over x minus 5 minus 5. Okay, so we need to simplify this. Let's get a common denominator down here. X minus 5 over x minus 5. All right, so that gives us 1 over 1 minus, let's just distribute this 5 through, so 1 minus 5x plus 25 all over x minus 5. Alright, so when we have a fraction in the denominator like that, we multiply by the reciprocal, so that gives us x minus 5 over, we can simplify this down to 26 minus 5x. There's the composition. Now for the domain. So the domain tells us to start with the inside function and find any restrictions there. So let's just start with h of x by itself here. So let's see here. Well, we know the denominator can't be 0, so I'll say x minus 5 does not equal 0, so we can't divide by 0, so x does not equal 5. So that's our initial restriction. Then we go through the entire composition process and see if we need to make any additional restrictions. Well, here we have a new denominator, so let's say that that also cannot be equal to 0, so 26 minus 5x also does not equal to 0. Thus, 26 is not equal to 5x, so x cannot be 26/5. Alright, so we have 2 points we need to remove from the domain. So I'll just put the final domain down here. Alright, we'll do it in set builder notation. X such that x does not equal 5 or 26/5.